I see thumbs up. Okay, great. So I'm audible. Yeah, let's start. So hi everyone. My name is Pranay. I am the head of event management at the Hackathon Society, and I will be giving this workshop on web service automation. And IFTTT is the main focus. So a little bit about myself. I have worked with IFTTT quite extensively. Developing web automations for a startup that I was working at, and I have worked with different IoT technologies through that, which is why I'm talking about this and sharing what I've learned with you guys. IFTTT isn't something that I've seen as a very common tutorial on the internet, and the documentation took me a while to get through. So getting my money's worth. But yeah, let's start then. I'm hoping that this can be an interactive session, so you guys don't have to put your cameras on because I get that. But from time to time, if you guys want to chime in or ask questions, please send them in through the chat. I'm going to keep an eye out, or just put your mics on and interrupt me. All right, so this is going to be a super short session, so let's just start then. So IFTTT is a software which stands for if this, then that, which is a little cryptic for now, but we're going to get into what it means. So what is IFTTT, right? For one, it's a web service, right? It works on the internet for the internet. It's made by a team of developers who have spent a lot of time, talked to a lot of popular services and integrated them, and made them talk to each other, which is what it does. It enables software communication. So you've got software like Google and all of its suite of products, Facebook, Twitter, um, to IoT home devices, to NASA, to the US government defense website. They've all integrated with IFTTT, set up services with them. So it's got a lot of possibilities for the interactions and the automations that you can make with it. It's community-based sharing as well. So a lot of people will upload the applets that they've made, and you can use them yourself. You can make your own for personal use, for public use. Um, and that's why IFTTT is so great. And these automations are done through entities called applets. Now, what are applets? We'll get to that in a second. And see what goes into making an applet and what goes into setting up this automation. So as you can see, I have 5 applets here. So in case the text is a little blurry, I'm just gonna read it out. So you've got open the garage when your BMW enters the driveway. This is integration of the BMW um, cars with a smart garage door, which is another company that's on IFTTT. Get a reminder notification if you haven't hit your Fitbit goals at a certain time. So this is Fitbit and your phone, right? Because that's where the notification would come. Forecast every day at 7 a.m. Tweet your Instagrams as native photos on Twitter. Automatically keep a playlist of your Spotify Discover Weekly. So there's a hidden subtle pattern in this. Can anybody try to guess what the pattern is here with all of these applets? Maybe in the chat. More often than not, I see someone. If this, then that. Yeah, yeah, exactly. So if an event happens, yes, Parth got it right. They get activated when a certain condition is met. Exactly. So when, for example, let's go to the first one. So open the garage when your BMW enters the driveway. So in this case, it activates when your BMW enters the driveway. Maybe let's go to the next one. Do you guys want to guess what is the activation event for the second one? Does anybody, um, you know? Yep, not hitting your Fitbit goal, but there's a bit more to that, Stella. It has to be specific. Exactly. Yeah. By a certain time. For the third one, it's pretty easy. The activation event is the time being 7 a.m. For the Instagram one, when you upload an Instagram photo. And then for Spotify, any guesses? It's when your Discover Weekly gets initiated. Yep. So that activation event is something we call a trigger, or the this part of if this then that, right? So it's an event of interest, and when it happens, it fires off the applet. So pretty simple for now, but what happens after that? So once you have a trigger, that's just half of your applet, or more specifically 40% of it. There is another 40% to it, which is the action, which is what you're supposed to do. So for example, here it's opening the garage, or sending a reminder to your phone, or sending you the forecast, or saving a playlist. So that's 40 and 40%. And then there's like an additional 20%, which is something called an ingredient, which is basically data that is passed from the trigger to the action. So for example, let me set up a laser pointer. In the tweet your Instagrams as native photos, the ingredient here would be the picture that you put up on Instagram, because you would put that picture up on Twitter as a native photo. For the rest of these, there is no ingredient involved because there's no data per se that is being sent between the two. So for example, when your BMW enters the driveway, opening the garage does not have anything to do with, let's say, which car comes in or what time it comes in, or um, other such information. And it's very similar for the rest, except maybe Spotify, where you have to know which playlist to save, right? But that's internally handled by Spotify, so we really don't have much visibility on it. Right. So that's an applet. So let's look a little, more in depth at triggers. And so yeah, so to create your own applet, it's pretty easy. All you have to do is IFTTT, that's IFTTT.com, create an ID, and you can just start creating applets from the get-go. It's super easy, takes a few clicks, and it's very intuitive to do. So I'm going to let you guys do that, on your own, but I will go a bit more into detail about the different parts of, a trigger and an action, and look at them more in depth. So here I've pulled up a Google Calendar service and the list of triggers with it. So let's say I'm building an applet because I have a very messy lifestyle, but an organized phone, for example, like an organized calendar. So my calendar has the set or an event for each time my guest enters, or I have somebody coming home, let's say. So then I would select, okay, Google Calendar will notify IFTTT when any event starts, or more specifically, a set number of minutes. So let's say 20 minutes, right? There's multiple examples of triggers, and hundreds of services on IFTTT with 10s, 15, 20 different triggers under them. So there's a lot of possibilities here. So, but for the purpose of this, thought, let's go with this trigger that I've outlined. So any event starts. So let's say I have a Google Calendar event of, guests coming home, maybe. So this trigger will fire 20 minutes, 30 minutes before I can set it. And what it does is I can hook it up to an action. So let's say I have this robot, which is an automatic vacuum cleaning robot. So I could set it to start cleaning. Now, automatically, I've made sure that every time a guest comes home, 30 minutes before they're scheduled to come home, my Google Calendar app will let IFTTT know that it is 30 minutes before an event. And that's all it does. And IFTTT handles the rest. IFTTT then tells my robot software that it should start cleaning. and it turns on and it goes around, does its duty, all handled internally. IFTTT here is just something that makes two software talk to each other, um, which is it seems quite simple, but it's honestly really tough because each company works with different languages, different stacks, different APIs, and integrating that all is what IFTTT is so great for. All right, so are there any questions so far? We can take questions for about 5 minutes. Maybe. Any questions? Let me know in the chat. If you guys want to put your mics on, that'll be great too. All right, so I'm not seeing any questions, so I'm guessing this is straightforward. Okay, let's move on ahead then. So this is the second part of the talk, which is IFTTT for developers, and how do you make your product or your service talk to the rest of the internet through IFTTT. You could do this, yourself. I know Spotify has APIs that are available, Facebook, um, Google for sure, but the trigger action applet structure is something that is unique to IFTTT for now. I know there's a lot of competitors, but it's unique because usually your product could not continuously talk to, um, let's say, Google Calendars or Spotify and make sure that what is supposed to happen or the trigger has happened. That's extremely resource consuming, which is why we have IFTTT, and your product can talk to other services, other softwares. So the documentation is in this link. The slides will be made available to everyone, so you can check it out. The issue here is that you need to register your organization with IFTTT to be given access to their platform. And since we do not have a registered organization, I don't have stills from that to show you, but I can still go over the higher level overview of what it takes to build a product. So there's four major requirements. We'll cover three of them because the last one's quite self-explanatory. So the first is authentication. Then you have to set up actions from your service, like how we saw with the Nito robot. And you have to set up triggers, which is what we saw with the Google Calendar page and other such applets that had, let's say, the BMW or Spotify or Instagram. But before we get into that, it's really important that we talk about APIs because that is how IFTTT works. So an API is an application programming interface. That's what it stands for. It's a super complicated word for something that isn't that complicated. An API is just a program, right, that runs on the web. It's a server of sorts. So it follows the request response cycle. So it's essentially, you can think of it as how the world talks to your software. So for example, if I have the Spotify app on my phone and I click play, that data comes from the Spotify server, right? But the way that my phone gets that data is by making a call to Spotify's API, which is just telling Spotify, hey, I want this data, and this is how I'm going to get it. And that's the request. And the response is then Spotify responding with the data of your song. So this can even extend to, let's say, other apps or other programs sending requests to your website or your server and requesting data. Hence the request response cycle. You respond to a request and send back appropriate data. At some times, you can even not send back any data because these requests might be from unsafe sources or might be asking for private information or might not have authorization. And we'll get into that exactly after this. But as you can see, these APIs are basically designed by your own engineers. So if you need two APIs to talk to each other, it gets really hard because Spotify's API and Google's API is going to be extremely different. They're both tailored to meet their organization specific needs. And so IFTTT is your middleman that lets two APIs talk to each other and exchange data, which is what sets off the entire process. So for a trigger, the trigger would happen, and then IFTTT would be notified, and IFTTT would send that information across to the action software, who would implement that. So if that was a IoT company, that would mean that they would set off that action, maybe turn on a light bulb or open the garage door. Now we can move on to authentication, which is, I mean, everybody knows what authentication is, right? It's to make sure information is secure and private. But why is this important with IFTTT? It's because so many people are making so many applets that your information should not be accessed by somebody else or some other applet. Also, authorization or authentication is a way for that company to know which user is being talked about. For example, if I tell Twitter, tweet this picture, that's going to be really hard for Twitter because they don't know whose ID to tweet from. And that's where authentication can also come in, where authentication lets Twitter know whose ID it is and that that person has consented to putting the picture up because the username and password could only come from them. And that's done through IFTTT using OAuth or OAuth 2 in some cases. So basically what that is, and you can look at the second picture here, is that your client or IFTTT or your mobile phone sends login credentials to a server and they give you back a token. And this token can be used every time you ask the server for information so that you can basically validate that you are the person who is asking for data. So for example, if I was to ask on somebody else's behalf for, let's say, very private user information, I would be straight up denied that information by any server because I would not be able to send them a valid token. But suppose you have logged in to your Google account and then requested private information, that request would go through because of something called a token. Because when you log in, your PC holds on to a token that you can then use to or exchange for information via any server that you have logged in and it is valid on. So that's why we use token-based authentication in IFTTT. IFTTT basically gets access to that token and makes those API calls on your behalf. But this also means that every time you want to use a new service, you have to log into that service via IFTTT. All right, so now we can talk about actions. So an action is basically what your service does when a trigger is initialized or executed. So whenever this happens, IFTTT sends a call to your API. It says, hey, I've just received a request from user, and it passes the authentication token to let you know which user. Another great thing about the authentication token, and I forgot to mention it, is that IFTTT has no idea whose token this is because it's just a garbled set of numbers. But when it's sent to the server knows exactly who you are because they keep track of who it is, where the token has come from, who they issued it to, and other such information. So IFTTT just sends a request along with this token to to make sure that the request is legitimate, and make sure that your API can then enact that information. So each action also has to come with some data about it. So authentication information is one. And then you also have to send relevant data about the action that you want to do itself. So let's look at an example here. So let's say I have an IoT company, and I've made a service that has one action on it, which is something to do with a smart light. So maybe in the chat, what information do you think would be um, relevant here for your service to know when IFTTT says, hey, I want something to be done to this light? It can be super specific or super broad. There's a lot of right answers here. Specific time. Yeah, that could be if you want to schedule a light to be on, definitely. Alternately, it could just be real time as well, because um, it completely depends on how your API handles that, but specific time is a good guess. Anyone else? All right, I'll give you guys one hint to get you started on. So the first thing you need to know is which light bulb, right? Because as a user, I could own 5 smart lights. And if I'm just sending an authentication token, that's not going to be enough. Do I want light number 1, light number 5, the one in my bathroom, the one in my bedroom? Which one do I want on? So which light bulb is relevant information? Anybody else? Any other guesses? I have 2 more on this slide, but there are a lot of right answers. So any guesses? Brightness level. Yep, that's a good one. That is the next one I had here. Turn on or turn off or change the brightness level. This is also something that is very tough to specify, because if you just say, I want to do something to a light bulb, you need to know exactly what action, right? Nice. Change the color of your slide. That's the next one I had. Pretty good. So yeah, you can be as specific as you need to or as broad as you need to when you make an action, but also it depends on the service that you have. So if I simply say my action can trigger a light bulb, then you need to provide which light bulb, on, off, or brightness, color, and stuff like that. But if my action is super specific, and if it is switch light on and make it red, then I've already taken care of point number 2 and point number 3. And we could even specify right now to take care of the timing, in which case you're only left with which light bulb. So each of them has their pros and cons. The pros is extremely specific, great for your server. You don't have to handle a lot of variable information. But the con is that this is bad for the user, because what if I want to set a green light, or what if I want to set a blue light? You would think a workaround would be, oh, make a separate action for each of those, but then you have to handle all of those separately, which becomes um, it's basically technical debt. So that's something that you'll have to consider. But that's all there is in actions, that you get data, you set up an action, and with the authentication token, make that happen. The trickier part is triggers, right? So how does IFTTT know when something has happened? Basically, what it does is polls your API periodically. Polling is basically, at very specific time intervals, it will send a request and say, give me the last 50 actions. So this could happen once every minute, or once every hour, or once every second, but that is completely dependent upon IFTTT and how they handle it. So we really don't have much of a say in that. And when they receive some event that matches the trigger, it can call the applet or the corresponding actions server and tell them that, okay, I've received this, can you make this action happen? But there's an issue here, right? Can anybody guess what the issue is? There's a problem here related to user experience, a delayed response. You're somewhat on the correct track, not clearly there, not almost there. A delayed response is very close. What if our action is not in the last 50? Triggers may contradict themselves, abusing the API. Okay, yeah, all of those are great responses, and I have addressed each of them in these slides. So let's start with delayed response. So yeah, suppose my BMW pulls into my driveway, but okay, so let's say my BMW pulls into my driveway, but unfortunately, IFTTT polls once every hour, and it polled the BMW servers exactly 1 minute before I pulled in. So there were no actions when it polled. But now that I am in my driveway, waiting 59 minutes for my garage door to open is that's horrible, right? Because um, that's completely against the point of automation if I have to wait 59 minutes for my garage door to open after me pulling in. So we have to find a way to make IFTTT real time somehow, right? So that's something that it's been accounted for by IFTTT. So they have provisioned something called a real time request. So basically, what your server can do is keep track of the triggers or the events that are happening. So every time an event comes in, um, it can check, is this event something IFTTT told me to look out for? And if it is, then it can notify IFTTT saying, hey, IFTTT, can you send me a poll again so that I can let you know the next 50 actions? And what this does is, suppose 1 minute ago IFTTT polled and my BMW pulls into the driveway, then the BMW servers would go, hey, IFTTT, why don't you poll again? I think I have some information for you. And when IFTTT would poll again, then they would find that, oh, the BMW just pulled into the driveway and set off the garage door action. So that takes care of the delayed response. The triggers contradicting themselves is not really an issue that we could talk about because um, even if you have multiple triggers set up, they will set off different actions. It's up to the user's common sense to not create contradictory actions like, oh, when my BMW pulls in, open the door, but when my BMW pulls in, also close the door. Like that's not. Then you're just leaving it up to chance, because what if the door is already closed and the closed door goes off first and then the open door goes off after that? So then your door would open, but it could also open and then close. Like that's something that is completely luck based because of how network communication is. What if our action is not in the last 50? The real-time API takes care of that too. Suppose you have something that has a lot of actions. Let's say I am getting a ton of emails and I've set up my email. Every time I receive an email, IFTTT does some action. So if I receive, let's say 100 emails an hour, I might miss out on 50. So the real-time API helps with that too, because you can make sure that every time you get an email, IFTTT polls, finds that email, and does an action for each corresponding email. What else? abusing the API. Faulty data is again a designer and a developer's responsibility to take care of. So that's not um, something that we should worry about at this stage. We can assume that the data is going through cleanly. And yep, basically the last point is a lot of traffic and API calls. That is the last and most important concern. If you are running a small company, IFTTT constantly asking you for 50 actions can be very expensive, especially when you're using somebody else's servers because you have to pay money for that. I think Amazon Web Services, um, their databases can cost 25 cents for every million reads, which doesn't sound like much, but when you compare it to, let's say, Google scale, they probably pay $1,000 a day given how many get requests they have to cater to. So IFTTT also notifies your software when that trigger is no longer valid. Let's say I have deleted that applet. So IFTTT will notify my server saying, hey, this trigger is no longer in use, so you can stop keeping track of it. So this delete will then prompt your server to essentially stop keeping track of it. So it could be you could remove it from the list of um, I will get to that question. So you can remove it from the list of triggers you were keeping track of. So there is a question: isn't it free if it's under a certain amount of calls? I'm guessing you're talking about AWS databases. Yes. Yes, you are right. I know DynamoDB is definitely free under a certain limit, but let's say um, for a company that is small to medium, it is very probable that you would exceed that limit because with IoT or with companies that have to service a lot of data, you have to keep making service calls. So for example, in this situation here, 50 actions, that means 50 get requests each time. Now that's just one user's trigger, right? Imagine I have 1,000 users. That's already 50,000 reads that I have to make for one trigger. And IFTTT sends this maybe once an hour. That's 24 times a day. And slowly your number starts building up because that's 24 requests, 24 times 50,000 times 30. And soon you're left with a really large number that overshoots the free limit. So obviously, like at this scale, you can assume there's going to be 10, maybe 20 requests, right? But at larger scales, this is something that you should just be aware of. Does that answer your question? Awesome. All right, and then the last thing is further customizations, which is just passing of information from one to the other, which can again be taken care of in the action part of it. So they would send you that data. So you just need to let IFTTT know. Um, some other cool things that you can do with IFTTT without even being a developer or getting an organization is when you make an applet, you can do something called filtering, which is basically put um, JavaScript code between the trigger and the action. So whenever a trigger fires, it goes through that JavaScript code. And if your JavaScript code deems the trigger important enough, then the action goes through. This is something that's available in the premium version, which is why I didn't talk about it too much. But just know that that's a possibility, and you can use other people's applets that have JavaScript and use their premium to service your needs. But yeah, that is the end of this workshop. Like I said, not too long, 40 minutes. Does anybody have any questions?